Okay, in this video we are going to use the formula for torque, and in the previous videos or in the textbook you found out that torque is the force that is applied to along a lever arm to apply a force. So it's like it explains why we can lift things with levers and how it maximizes or makes the force that you are applying greater across this lever arm so that you could lift really, really big things with just a longer lever. Okay, the thing with a lever though is that it has an axis of rotation, and so if you are applying the force down, let's say we're trying to jack up a car here, you would apply the force here. The lever arm is completely maximized right here. So it is the force that is applied at a 90-degree angle to the lever arm. Okay, if we were to apply it right here, okay, it's not going to have as much of an impact because the lever arm is shortened, so the force won't be as exaggerated. And then of course, if you apply it right here, there is no lever arm, and so the torque will be zero and it won't be able to rotate. So I often think about, like, where is it the easiest to open a door? If you were trying to open a door, it would be easiest if you push it on the outer side. You know, like, think about those times when you've walked up to a glass door and you just hit it on the wrong side and it doesn't move and you just like stop and feel silly. Okay, that's because the torque is zero right there, because it's right at the axis of rotation. So if we look at this problem, it says a force magnitude 55 newtons is applied to a door. However, the lever arms are different in the three parts. Find the torque in each case. Lever arm of 0.80, so that's when it's maximized. We could think of that as right here. 0.6 meters, that could be right here, and then 0 meters right here. So we already know the answer to this one. This is going to be 0 torque. So I'm going to plug in my numbers here. We have 55 newtons for both of them, and then the lever arm is 0.80 meters. Plug that in my calculator. 55 times 0.8, and we end up with 44, and the unit for torque is Newton meters. And you're supposed to use an asterisk in between for your unit. And then we can do the others. 55 newtons times 0.60 meters. And we end up with 33 Newton meters. And then we already talked about the last one being 0 Newton meters. You're applying a force, but you do not have a lever arm. Okay, so there is our question for torque. It's just how can you increase your force by distributing it across a lever arm.